Okay, year 9 students, this is seventh video about statistics. We are going to study the shape of histograms and stem plots. Okay, so there are few technical names for different kinds of shapes, or we might call them distributions. Okay, so let's say there are some technical terms for this lesson. Alright, so you need to understand what do we mean by symmetrical, normal, bimodal, skewed. Alright, and there are two types of skewness, positive and negative. Alright, okay, so let's have a look. So first of all, sometimes the distribution looks like symmetrical. So there are two types of symmetrical distribution. One is normal, the other is bimodal. Okay, so what do we mean by symmetrical? That means the distribution, the shape of the graph or the chart on the left hand side would be a mirror image of what happened on the right hand side. Alright, okay, so let's have a look. If I draw a line at the center of the distribution, you see left hand side, right hand side, they are fairly the same, but of course they are not exactly the same, right? But they're fairly the same, so we can call them symmetrical. So it's this one. So see the left part and right part, they are quite similar, right? Okay, so they both are called symmetrical distribution, but if you got only one peak at the center, so at one peak at the central part of data, this is called normal. Okay, if you got two peaks, over here, then this is what we call bimodal. All right. Okay, for the normal one, okay, that's three features. The first one, the mean, median, and mode are roughly in the same position. Okay, so mean, median, mode, they're very close, and they should be around the middle part of the data. Alright, and also there's only one mode, of course, it will be at the center. Alright, most of the data is roughly grouped around the center of distribution. That's quite obvious, right? Most of the data are grouped around the center of the distribution. Alright, so on the other hand, if you got bimodal, the mean and median roughly the same, so mean and median still around that purple line, but there are two modes, or technically there should be still one if you got two different values, but I mean there are two peaks of the histogram and either side. Alright, and the data is grouped at the two ends, so you see, okay, so there are two what we call clumps, alright, at either side of the data. Alright, so that's symmetrical. How about if the data is not symmetrical, is asymmetrical, then we call them skewed. Alright, so you see the word skewed. Okay, so there are two types of skewed. One is positive, the other is negative, so both are symmetrical. Alright, for positively skewed data, okay, so you see the shape is like, okay, the largest group of data will appear at the left hand side, which is a smaller data. So when it is a positively skewed, that means you got most of the data at the with a smaller data, or at the left hand side of the data. On the other hand, if that's negatively skewed, you got most of the data at the larger end of the data. Alright, okay, so well, we can use the terms like clumped towards the left hand side for positively skewed, clumped on the right hand side. Left hand side means the smaller data, and right hand side means the bigger data, right? Okay, left hand side means smaller data, and right hand side means greater data. Okay, they are clumped. All right. Okay, so we focus on this part. Okay, you see this part and this part, right? Okay, and there's long tail on the right hand side. Okay, so use this term as well, tail. Okay, long tail on the right hand side. Okay, so on the right hand side there's long tail for positive skew. Right hand side means greater data, and long tail on the left hand side. All right, so here what we're talking about is here. So this is what we call tail. Okay, this is what we call clump. All right, so see here. Okay, so that's kind of description you are going to use and observe. Okay, and for the positively skewed, mean, median, mode are most likely on the left hand side, so they are smaller. Okay, they are towards the smaller parts of data. Okay, and for the negatively skewed distribution, the mean, median, mode most likely to the largest side of the data. That's the right hand side of the center, right? Okay, all good. Okay, so let's have a very quick summary what we have learned so far. Okay, so let's see. So for all distribution, we can separate them into two types. One is symmetrical. The other is asymmetrical. Okay, for symmetrical data, there are another two. The two types. For asymmetrical data, actually there are three types. Okay, I will show you why. Okay, so for symmetrical data, we got normal. I should use another type. Normal and bimodal. Okay, asymmetrical, you got negatively. Should make it bigger, right? Negatively skewed, you got positively skewed, you got others. Okay, so let's see what happens if there's more normal. For normal, the shape of the data, if represented in a histogram, you will see things like this. Okay, bimodal, you will see something like this. Okay, for negatively skewed, you will see what? You will see this. Okay, the peaks, the clump is on the right end of the data, and positive skew is like this. And there are others. Others means it's very hard to say whether it's negative or positive, and they are not symmetrical as well. Okay, for example, you might see things like this. Okay, so they are not symmetrical at all, and they are not negative or positive skew. Right? Okay. So that's what we have learned. Okay, so let's have a look at some other types of representation. Sometimes you might use this plot. This is what we call stem plot. You got stem and leaf. Okay, so when you look at the stem plot, actually there's a visualization to help you to see what kind of distribution it is. For example, For the first one, you see the shape of it is like this one, right? So you see, okay, the data, the clump, okay, the most of the data, they concentrate at the greater end of data. So this is what we call negatively skewed. Okay, for the second one, you see, it's like this. It's like what we call a bell shape. So you got the clumps at the center, right? And the left hand side, right hand side are fairly symmetrical. So this is symmetrical, and possibly you would say this is normal. And the last one, if you see this one, it's quite obvious. Okay, the peak or the clump is on the smaller end of the data, okay, and you got a long tail on the big end of data. So this is what we call positively skewed, right? Right? Okay, so there are different ways to visualize what kinds of distribution they are, right? Okay, so let's have some examples. Okay, the first type of examples is like you are going to describe the histogram and then plot by using the technical terms you have learned. Okay, so for the first question, what kind of distribution? Okay, so for distribution, you might observe how many peaks, 1 or 2. Of course, they got the highest one 7, but the other is at 6, which is quite high, and other places they're quite low, right? Okay, so we got 1, but 2 peaks, all right. And so this is what we call symmetrical. Are they symmetrical? They are not perfectly symmetrical, but you can still argue that they are fairly symmetrical, right? If we draw this line, so left hand side, right hand side, they fairly like a mirror image, all right? So let's say the distribution is symmetrical and not normal bimodal, right? Okay, let's say spelling, right? Okay, so this is because you need to give reason. Okay, because what? You need to give reason. All right. Okay, so possibly we need to use smaller word. The reason is it has 2 peaks at either end of the distribution. Okay. Okay, and also there are 2 clumps of data surrounding these 2 peaks. Alright, so that's second observation. The third one is the left side of distribution is a mirror image of right hand side. Okay, so there are 3 points you need to write. Like, okay, you need to point out that 2 peaks. Also, then you need to point out the 2 clumps of the data surrounding 2 peaks. All right. Okay, so the clumps means you got like a hue, right? You got the top, you got the the topmost part, and then both sides they are a bit lower, but they becomes lower gradually. Okay, and also when you need to mention the mirror image of the left hand side, right hand side, right? Okay. Okay, so B, what kind of distribution it is? Okay, so how many peak? This time there's only one peak. Also, do you see any mirror image from left hand side, right hand side? Yes. Okay, so let's say this distribution is symmetrical, and what is normal. Okay, but there's only one peak. The reason it has one peak, the data is clumped around the peak. At the central and at the center part of the distribution. Okay. The left hand side of the distribution. Okay, and is fairly a mirror image of the right hand side. Okay, so that's it. Okay, so that's a description for this one. Okay, let's say C. Okay, so for this one, okay, how many peak? There's only one peak. Okay, do you see the symmetrical any symmetry? Okay, from the center. Okay, you might still draw a line here. Okay, so you don't see the symmetry of because obviously the left hand side of the distribution got much greater heights than the right hand side. Okay, so this is not a symmetrical distribution, so that's a skewed distribution. But there are two types of skewness. One is positive, the other is negative. So what sort of skewness we have? Okay, so for this one it should be positive. Alright, so the distribution is, let's say, positively skewed. Alright, so the reason, okay, the peak and clumping of data is to the left and side of the distribution. Also, you need to mention that there is a long tail to the right hand side of the distribution. Okay, so that's kind of description. Alright, alright, so okay, let's see how could we. So when you answer this type of question, you need to mention the peak or the peaks, and also you need to mention how data is clumps around the peak, and also you need to mention whether it's symmetrical. If it isn't, then it's skewed, and then you need to mention where's the tail, to the left hand side or the right hand side. Okay, good. Okay, so let's see another one. Okay, so comments on the shape of the distribution of this one. Okay, so when you see the distribution of this one, so it's a perfectly symmetrical distribution, right? When you draw a vertical line down to the center of the data, so see the left hand side, right hand side, they're just identical. Okay, so when you say the shape, okay, you can just the comment. Okay. Comment. Okay, for part B, let's see. Okay, so because the data is completely symmetrical, so we see that the mean and median should be at the center, at the middle part of the data, right? But mode means, because this is what we call bimodal, the mode should refer to the two peaks. So the mode should be 1 and 7, but the mean and median should be both 4, right? Okay, so you don't need to calculate because the distribution is a perfectly symmetrical bimodal. All right, let's write the data. Since the distribution is a perfectly bimodal okay, mean and median must be equal to the middle data, which is 4. Okay, how about mode? So there are two modes. Okay, mode means the two modes are basically 1 and 7. Okay, which are the most popular, the most frequent data. All right. Okay, so see, so if we see on the graph, so both mean and median is then the center part of the data. So that's 4. So that's vertical line means mean and median. And okay, equals median here. And for mode, okay, there are two modes. So here, this both. Let me draw the vertical line, it will be easier to understand. Okay, so these are what we call mode. All right. Okay, so basically the note is, if a data set is completely symmetrical, then the mean must equal median. Okay, so if it's a normal, then the mode would be equals mean and median as well. But if it's bimodal, then the mode should be at either side of the data. Okay. Okay, so let's see question 4. Okay, so first, whether this is symmetrical. It's not perfectly symmetrical, all right, but we still treat it like a symmetrical distribution in statistics. Okay, so the first question is the graph symmetrical. You answer yes. Okay. It is what we call symmetrical, and normal. Okay, what is the mode? Mode should be x equal 4. So that's the the most frequent data. So for x equal 4, there are 8 of them. So can mean and median be seen from the graph? Yes, it should be around 4, but you need to calculate, right? Okay, so you need to calculate them. Yes, we still can find it, but you need to find it out. You can't just say therefore, because this one is not perfectly symmetrical, so you need to calculate. All right. So the reason is, since this is symmetrical but not perfect, this is not a perfect symmetry. This is not a perfect symmetry. We need to calculate for the mean and median. Okay, so let's see how could we calculate the mean and median. Still remember how to do it? Okay, so for histogram, possibly you need to make it into frequency distribution table, right? Okay, so it's not evenly spaced, but we don't care, right? Okay, so let's say x number of TVs, so whatever data it is. Okay, so that means this one should be discrete data, because number of TV should be discrete data. Okay, so and here's the frequency, which should be 1, and should be 2. For 3 should be 5. 5 should be 6. 6 should be 4. 7 should be 2. Alright, so then you're going to find the mean. Okay. Still remember the equation for mean? It's like this one. Okay. Right. So let's say what's the total frequency here? Okay. So the total frequency here should be 1 plus 2 plus 5. Okay. Plus 8, and total frequency should be, for me, 28. Okay, and we find that's total fx. Okay, for total fx, alright, so I might create a little bit room for you here. Okay, let's write another column. So that's fx. Frequency times x, still remember that? So 1 times 1 is 1, 2 times 2 is 4, 15, 4 times 8, 22, 30, 24, 14. Okay, so you basically just add them up. Okay, so summation of them will be, okay, let's see. Should be 120, right? Okay, so therefore our mean is 128, so is about 4.3. Okay, so 1 decimal place. Okay, so that's for the mean. Okay, so we need to find another one, which is median. How could we find median? Okay, so median. Okay, still remember that median is middle data. And the position, location of that median is number of data, so there are 28 of them. 28 plus 1 divided by 2. Okay, so that means it should be 15.5 data. Okay, so that means you need to find the median is 14th data plus 15th data and divided by 2. Okay, so you are going to find the 14th data and 15th data. Okay, how could you find the 14th data? So let's see. So you need to count, right? So the data is already in ascending order. So 1 plus 2 is 3. 3 plus 5 is 8. 8 plus 8 is 16. Okay, so you already passed that's 14 and 15. So both, you could say both 15th and 18th, 14th and 15th data are both full. Okay, so what do you have is 4 plus 4 divided by 2 is 4. Okay, so that's what we've got. We got 4. Okay, so medium's 4 and mean's 4.3. Okay, so they are quite close, you see, because that's the nature of that symmetrical normal data. So mean and median must be very close. They are not equal because this is not a perfect symmetry. If that's a perfect symmetry, then they should be equal, right? Okay, that's the first one. Okay, let's do another one. Okay, so let's have an overview. Okay, so let's see question 5. Okay, so for question 5 is this distribution is symmetrical one. Okay, of course it's not. Okay, so no, actually it is positively skewed, right? So what is the mode? The mode should be the most frequent data. So the highest frequency is 45. Is 45, right? And the data for it is 2. Okay. So mode is 2. Okay, can the mean median be seen from the graph? If so, what are they? Okay, so we can, of course, we can find the mean median mode, but you can't just look at this because it's not perfectly symmetrical. So there's no way you can tell exactly what's the mean and median at this stage, but we can calculate this. Okay, so to do that, remember you need to draw a frequency distribution table. Okay, still remember that. Alright, so let's draw a frequency distribution table. Alright. Okay, let's say this is what we're going to do. Okay, so the first line we're going to find x, second one need to find frequency, and third column fx. Okay, so for x equals 1, okay, so that 25 data. Okay, fx 25, x equals 2, that 45, 90, okay, and so on and so forth. Okay, and you might just try to do that by yourself. Okay, and then we need to check the answer. If you got them all correct, you might find the mean and median from that table as well, right? Okay, I'm going to give. Okay, so here's the distribution table. Okay, so how could we find the mean? All right, let's say, and so C. Okay, so let's find the mean. Okay, mean should be summation of all fx. Okay, so the sum of all fx should be 322 divided by summation of all frequencies, 122. Then you will have 6.7. Of course, I round up to 1 decimal place. Okay. how to find the median. Okay, remember median is the middle data. Okay, so its position could be found by n plus 1 divided by 2. So that's 61.5. Okay, so that means it should be between 61st data and the 62nd data, right? Okay, so median would be 6 data plus 62 data, 6 divided by 2, right? Okay, so let's find 61st data and 62nd data, right? Okay, so you need to see the table. Okay, you add all the values until you pass that 61st and 62nd, right? So when you goes from first, that 25 goes to second, 25 plus 45, this will give you 70, right? 70 already passes. That's 61 and 62. So that means both 61, 61st and 62nd are 2. Okay, so we know that's 2 plus 2 divided by 2 should be 2. So median is 2. So when you compare these two data, the mean is 2.7 and the median is 2. So they are different, aren't they? Because the data is no longer symmetrical. So you will see there's some difference between the mean and median. Okay. So that will be our question 5. Okay. So let's see the last question. Okay. So for this one, you need to observe. Okay. So they give you a distribution like this. So first of all, what kinds of distribution it is, right? So, okay, is distribution positively or negatively skewed? Of course, it's not symmetrical because you see the peak is on one side. Also, you see a tail. So there's a tail right here. Okay, so this is because the peak is on the smaller data on the left hand side, so this is a positively skewed data. All right. Okay. Is this distribution positive and negative skew? Explain why. So you need to explain. You can't just state the distribution. Okay. So what kinds of explanation you need to put in? So we say it is positively skewed. Okay. Because the mode and clump of data to the left of the distribution. And sorry, just a second. And there is a long tail. Right. Okay. So I think that would be the explanation. Okay, you need to mention the mode, and that means the peak, and also the clumping of data occurs on the left. So most data they group on the left hand side. There's a long tail right on the right. Okay. Would you expect a median of the distribution to at the location A, B, and C? Okay. So median should be the middle of data when all data are in in ascending order, because most of the data are clumped towards the left. So you need a medium which is close to the left. All right, and of course C is not the option because it's far to right. Okay, and how about A? So you see A, which is not at the center of that group of data, is a bit to left. Okay, so I think B will be the suitable answer, right? Okay, right, so we'll say that the B will be the answer. So we expect that the median suit. All right. Okay, so that's the explanation. Okay. Okay, so that's all we have. That's all about this video. So we've done different kinds of distribution. There are symmetrical, skewed distributions, and we also learn how to apply our previous knowledge in terms of finding mean, median, mode to different types of distribution. You need to be aware of the position, the relative position, mean, median, mode when it comes to different types of distributions. Okay. For practice, I would like to encourage you to do some practice here. So this one is really basic. So practice 7. Okay, there's no calculation here. Okay, you only need to say things like what kinds of distribution it is, right? And I give you the answer as well. So that's a self practice. And also there's a more difficult, more comprehensive assessment on this one. So because this will be our last video on statistics, so I would like you to hand in an exercise on assessment on that, all the things we've just learned. Okay, so there's a group of data about the heights of 52 females attending summer camp. Okay, so you need to find the data, you need to find the mean, median, mode, and range. Okay, so that's what we have learned before. Okay, and then you need to group them. So remember how could we group the data? Because when there are too many data, we're not going to do it one by one. So we're going to group them into class intervals. Okay, and you need to construct another frequency table using that these class intervals, and then you need to construct a histogram for heights. Okay, then you need to describe the shape and distribution. So what kinds of shape and distribution? Of course, that's what we have learned to date, is about what kinds of distribution. All right, and they are asking you to do another new frequency table by using class interval 5 cm. So it's very interesting assessment. And so I would really like you to do it and hand it to me, so you will be part of our assessment to know how much you have learned during this period of time, because you study at home. So I really would love to see how much you really understand, okay, without me providing you the answers, right? Okay, you just need to do it. I will collect them. I try to have feedback to you guys. All right. Okay. So that's all about this video. Okay. See you next time.